Hi boys, first worked example for topic 1, looking at an expression or an equation, stating the constants and finding all the like terms. So I'm just going to turn my pen on and we're going to highlight the parts of the question that we need to focus on. So the first part is whether or not it is an expression or an equation, whether or not there's any constants, and the final part is finding all of the terms that are being used. So we can see here that there is an equal sign. So that allows us to identify that this is actually an equation. So if I write an equation, okay, as there is an equal sign, I've got my justification. The next part is whether or not there is a constant. Okay, just turn my pen on again. And we can see here there is a 7 by itself, indicating that there is at least one constant. And then finally looking for all the terms. So as per our previous slides on this PowerPoint, there are our terms are pronumerals, have pronumerals and numbers, and all numbers. So looking at each of our terms, we have 3p, we have 4q, we have negative 8pq. Our 7 doubles up because constants can also be terms. All right, and our final one is our 2r. So if you write those all out in order, you have 3p, 4q, minus 8pq, 7, a constant, and 2r. Second question asks us to identify an expression or an equation, state the constants again, okay, and list all of the terms. Okay, so very similar to the last one. So this time we identify that there are no equal signs, so therefore it is an expression. And I'll justify my answer as there is no equals sign. Next thing to look for are whether or not there is a constant present. Okay, if we look through our expression, we can see that we have a 2. And we notice that the sign out the front is a negative 2, so then our constant is negative 2. Finally, we're looking for each of the terms. So here we go through and we have a look and we can see that we've got 2x squared is one term, our positive 3x is one term, and our negative 2 doubles up again. So we have 2x squared, we have 3x, and we have minus 2. Okay, next question. Example 3. Patrick is 2 less than double Oscar's age. Identify the variables and define each using a pronumeral. So in this particular example, variables would include Patrick's age, and Oscar's age. So looking at these two, we have two names, Patrick and Oscar. So I'll just underline Patrick and Oscar. It would be easy for us to identify each age based on their first letter of their first name. Okay, so for example, our pronumerals then would be P representing Patrick's age, now, Oscar's an interesting one because an O looks also like a 0, so I would avoid using that one. So in this particular case, we might just use X. So x equals Oscar's age. Example 4. Max has P pencils in his pencil case. He takes out a pencil. How many are left? Write a scenario using algebra. Okay, so again, we need to think about all our conventions. So in this particular, we look for what sort of sign are we going to be using. So takes out would indicate a subtraction. How many left is probably the main part of the question. Okay, we might indicate that by L. And obviously our P equals our pencils. So if I was creating an equation there, we've got how many are left. So that's got to have a total. We've got the total number of pencils that he starts with. Sorry, I'll just turn my pen on again. In this case, P, and it's going to be minus 1, because 1 was taken out, and we've got our equation. So L equals P minus 1. Example 5, 3x plus 7y plus 2xy minus x plus 8y. Okay, and we're simply asked to simplify the expression by collecting all the like terms. So here I would start with identifying which are the like terms. So for instance, we have 3x, we have x. Okay, so we might start by writing that out. So 3x minus x. Now we need to go and find the other variables. So in this particular example, we have 7y and 8y. So I'll indicate those with a triangle around them. Okay, you can see that they're both additions, so we can go plus 7y plus 8y, and then we're left with one final term, which I'll make a square. All right, which is plus 2xy. Okay, now next line of working, we'll start to perform some of those sums. So in this instance, 3x minus x would leave us with 2 lots of x. 7 plus 8 would leave us with 15y. And finally, we've got 2xy. Example 6, we're looking to simplify the following using algebraic conventions. Okay, 2 parts to this one. So again, looking at A, and I'll turn my pen on again, sorry boys. So indicate the question that I'm doing. We have 3 times A plus 4 times B. Now algebraic convention allows us to get rid of the time symbols between coefficients and pronumerals. So in this particular one, I can start with 3A, all right, plus 4B. Right, and all I've done there is eliminated the operation symbol. In the example of B, okay, here we've got 2 times x divided by b. Now, in the first step, I could get rid of the time symbol between the 2 and the pronumeral x. So that would leave me with 2x divided by b. In the second line of working, I would get rid of the division sign and express this as a fractions. And you'll notice that these conventions are outlined on the conventions page in the PowerPoint, so make sure you've gone over that before you start this worksheet. Okay, and I have 2x over b. Okay, example 7, demonstrate your knowledge of the distributive law to expand the following. So in this particular example, we need to remember that our distributive law allows the number outside the bracket, or the letter outside the bracket, to be multiplied by each term inside the bracket. So one of our first steps might be to include our arrows, right, to make this a little bit easier. So I'll do that as best I can in the space. All right, so that we can follow through our steps. So starting with A, all right, we notice that we will have A times B plus A times 4. Start using algebraic convention here, so we get rid of the time symbol, so we have AB plus A4, and we don't write it that way. So we can automatically go back, if I just rub that out, and we can make it 4 lots of A. Okay. B, we have x times 2 plus x times y. We also have y times x plus y times 2. And again, conventions need to be put in place here. So we have 2 lots of x plus x, y plus y, x plus 2 lots of y. Now, x and yx are essentially the same. So what I'm going to do here is just erase quickly the second term and make it the same as the first term. Now we can collect our like terms and finish simplifying these expressions. So I have 2x plus 2 lots of x and y plus 2y.